So for our last live example, please open your Robinhood historical data notebook here on the navigation side, and you'll see something very similar to what we have with our alpaca call, and we'll go through this line by line. So within the documentation, you're going to notice that each of these Robinhood API calls all begin with Robin stocks dot Robinhood. So that's the reason for the multiple here as compared to the previous that only had the one call. So we're going to go ahead and assign the Robin underscore stocks dot Robinhood as R, so that we can access each of these Robin underscore stocks dot Robinhood calls. So for these, we'll show you what that looks like when we go to get the stocks and get stock information. So we're going to assign that as R. We're also going to again import our pandas as PD so that we can read our credentials file. So again, making sure our credentials file has stayed within our course content folder. We did edit that in our previous sections to add our Robinhood username and password so that we can log in. And again, that way I don't have to show you my credentials here on screen. So very simply, again, as we covered, we're going to assign our credentials utilizing the pandas JSON reader so that we can parse those in here, and then we're going to look up our Robinhood username and our Robinhood password so that we can log into the site without again me having to put my live initials on here, my live credentials on here. So for Robinhood, we do have to first log in before we can access the information. So very simply, this line is just to use R, so using our r.login API call and then passing it our username and our password so that it knows it's us accessing the information from that Robinhood call. From there, we are going to assign our variable AAPL equal to our R dot get stock historicals. So we're going to actually utilize their get stock historicals call, and we're going to pass it the ticker symbol Apple as in our previous examples. We're going to tell it we want data at 5-minute intervals, which is as fast as you can pull currently for Robinhood. So their data is not 1-minute intervals like we were doing in our last calls. The quickest you can get is 5-minute intervals. And we're going to tell it we want data for the current day in which we're making the call. Down below that, we are going to convert it to a data frame. So unfortunately, we can't use that same .pd call because of what this data frame is that's returned, because it's a dict return. But what we can do with this handy pandas functionality is actually utilize its capability to take in a list of dictionaries and convert that to a data frame. So we're going to go ahead and run that, and I'll show you what that looks like. But to show you what AAPL would look like before we assigned it to the data frame, just so you understand what that call brings back, we're going to actually comment this out and run it. Again, you don't have to do this on your own. Just follow along with me here in this example. So we'll go ahead and we'll run this. One thing to note about Robinhood is the two-factor authentication, so it will ask you for that validation code. So give me just 1 second while I go ahead and type that in. So one thing you'll notice with Robinhood, and this actually frustrates me very much when I'm coding, is that during the day when you're running code and you're accessing it, if you're actually doing it during trading hours, you don't seem to have this block, this normal issue. But when I do run this after hours or outside of trading hours, I do typically get a block the first time, and I very simply go back, re-execute, it'll send me another code, and typically the second time it does go through. So you can see I've hit enter now, and me not getting an error tells me that this likely went through. So I'm going to go ahead and show you what is assigned to our AAPL variable. And you can see that return list of dicts that has come back, dicts being dictionaries that you can see were the return of most of these. So you can see that dict call, that their dict return that comes back from those specific calls. So you can see every 5 minutes, and I believe this is UTC time, you are getting that same open, close, high, low volume information, except from our Robinhood source. So again, very ugly to read, but it's there. It's a great quick way to access that historical information. So now we are going to uncomment our AAPL reassignment here, where we are taking those list of dictionaries, using pandas to put that into a data frame, and giving you a more clean output of what these look like. And we're going to go ahead and rerun it. We're going to have to put in our code again and likely get blocked and rerun. And now that this is completed, we're going to go ahead and rerun our blank here to show you what AAPL looks like in our data frame format. And now you can see that we have our 5-minute calls here in this easy to read pandas data frame, where we can quickly go by line and see, okay, what's my open, close, high, low, and volume information for these, again, 5-minute intervals. So I would go ahead and ask our audience to run this last line. For time purposes, I'm gonna go ahead and follow along with you, and we'll get this to run. But let's pop this up, show you what that looks like. So here in this notebook, you'll notice that we've got an easy to read, easily parsable, and good way to go back and review that data call. So as we look at these 5-minute intervals here for the return, a little different again from our 1-minute intervals of what we requested from Y Finance and Alpaca, you still have a very healthy source of information that shows you, that open, high, low volume data from the Apple stock ticker. And again, 5 minutes may be good for what you need. So again, I would just recommend is you choose the right one for you and your algorithms that review all of them, pull the information out, see which gives you the best call, best format, easiest to work with for your needs as you work on building out your algorithmic trading assistant.